All right, step functions. Which is probably going to be brand new to you guys, right? It gets its name because basically it's going to be those piecewise functions. So you remember piecewise the other day how we had like little chunks of the graph that were like at different rates or whatever, and then they kind of went together to make like a full one. Same concept's going to happen here, except for they actually look like stair steps, kind of going up or down, like depending on our setup, which you'll kind of see when we start graphing them out. And those come from either a floor function or a ceiling function. So the floor function, I don't know if you can see these pictures very well, but basically what it is, so it's not like the absolute value lines. They have like little bars kind of going underneath there. So if you didn't get those marked in, like the floor one, it's so hard to tell because they're so tiny there. But basically it's just got little lines underneath there. What that means is you're going to round down. Okay, so there's an example in the, or the ceiling function means you're going to round up. There's an example in the book that talks about like post offices and mailing packages. How post offices work is like, say you go in and they say, okay, if your package weighs, 3 ounces, you got to pay this much. And if it weighs 4 ounces, you got to pay, a little bit more because, it costs more. It's for them in gas and whatever. So when you go in there and you weigh a package, say your package comes in at like 3.75, okay, what rate do you pay? Do you pay the lower rate for 3 ounces or do you pay the higher rate for 4 ounces? You're always going to pay the higher rate. Even if your number came in at like 3.1, just over 3 ounces, they're always going to bump you up to that higher rate, just because that's just their rule and their standard of how they do this, okay? So typically what they do is no matter how much your package weighs, you have to pay like a flat fee. So like the book actually has an example here of what the charges were in 2007. So their flat fee, if it was just like 1 ounce or anything below that, was 70 cents. And then each additional ounce you went up, you had to pay an extra 17 cents. So that's kind of like what we've been doing where, start with a number and then, constant increase or whatever. But now we're going to throw this rounding thing in. So like I said, say you have a package that weighs like 1.1 ounces. You don't get to pay 70 cents anymore. Because it's even just a smidge over 1 ounce, you have to jump up to the 2 ounce category, okay? So then what that ends up looking like for your graph is something like this, okay? So see how it kind of looks like those staircase type things? So that's called the step function, okay? And that's what we're going to be kind of looking at here. But like I was kind of saying, so this floor function and the ceiling function, whatever number you put in there for a floor function, you're rounding down to whatever the number, the integer that was below that. So like say I put in like 3.4 or something like that, you would round that down to 3, okay? Now the opposite one of that is the ceiling function. So those, it's the same thing except for your little lines are up top there with whatever your X is in there, and this one you're always going to round up. Like I said, even with that post office example, even if it's just like a hair over an ounce, they automatically round you up to the next biggest category, okay? So we'll do some in our packet here, kind of solving those out, the floor and ceiling function stuff, and then we'll get into some graphing with that. Okay, so for the first one here, they just want us to evaluate each of these, okay? So this first one is a floor function because the lines are underneath, so the floor function means we're rounding down to the nearest integer. So if that's 6 2/3 and we have to round that down, what's it going to round down to? Just an even 6. So that would be 6. Next one here, same thing, we want to round down. Be careful because it's a negative. Think about negatives on like a number line. It is negative 11. So here, like if I had like negative 11 and negative 10, and I had like that negative 10.01, which of those is smaller? Is it the negative 11 smaller? So you have to round down to negative 11 there, which is confusing because you're like, well, 10 is less than 11, but when it's on the negative side, you got to be very careful with that, right? And a number line is kind of an easy way to think of that if that's confusing. So that would round down to negative 11 because negative 11 is less than that. What about 2 pi? And this one's a round up one. Not 3 pi. We would solve it, yeah. So what I would do is I would just use my calculator, figure out approximately what 2 pi is. So you would just do like 2, and then if you haven't used your pi button before, it's the one above the division sign, how it's like that up arrow there for like our powers. You just go second, and then that button for pi. So So 2 pi is 6.28 approximately. So if that's about 6.28, and this one's a ceiling function where we're going to round up, what would that round up to? It would round up to 7. Yep, so if they give you something like that where it's like, you know, something that you got to solve it out first, then do your rounding up or down. And then we got a ceiling function here on 27. It stays 27, yeah. So if you ever get one that's already an integer, already like your whole number like that, you just leave it as whatever that number is. So sometimes they'll kind of throw that in to trick you. Okay, so now let's attack a graph of this. Okay, so graphing this, couple things we got to note here. Do you guys remember how to graph it when it's less than or greater than sign, what the difference in the circles is? Like, yeah, open circle and closed circle. So you remember how, like, if it's like an open circle, that works for the ones that are like less than or greater than with no signs underneath, like no equal signs underneath. And then if it does have the equal signs underneath, do you remember how those are the filled in circles? So that's kind of what those are getting at there. Okay, so here what we want to do is they give us a chunk of numbers for the x. So we're thinking of numbers from -3 to -2. And any of those numbers in the middle there, we're going to round up. Okay, so what you could do is you could just think of a number, like what's a number that would be between -3 and -2? Okay, so if we think of -2.5 in our round up function there, what would -2.5 round up to? Be careful because it's in the negative side, -2, yep. So that's kind of tricky because it's in the negative sign, but the next bigger number than -2.5 would be the -2. So then I could do the same thing with my next category there. What's a number between -2 and -1? -1.5 would work. And what would that round up to? -1. Okay, number between -1 and 0. -0.5 would work. Okay, and what will that round up to? 0. And then same thing, number between 0 and 1, 0.5. And you can pick any number will work with this. I'm just using some examples here. What's that going to round up to? 1. And then the last one there, I'll just use 1.5. So if we do 1.5 and round up, 2. Okay, so when we graph this here, these are all our x values, and these are our y values. Okay, if you want to put that above it for y, that might be kind of helpful to kind of see that there. Okay, so when we graph this out, again, these are going to be like a range of numbers, okay? So if it doesn't have the equal to line underneath, we're going to use that open circle. If it does have that equal to line underneath, we're going to use the closed circle, okay? So our first one there is going to be on our x from -3 to -2, and then it's going to be at the height of -2. So what I would do is I would go to the height of -2, which would be like right here, and then it's going to go from -3 to -2, and it's going to be an open circle on -3. Draw a little line in there saying it goes to all those numbers in between, and a closed circle on -2. Okay, so the y coordinate here tells us how high it is, so we have to go down to -2 for the y, and then our chunk of line is going to be going from -3 to -2, open circle on the -3 because it's not equal to there, closed circle on the -2 because it is equal to on that. Everybody follow me so far? I know the graph is like really tiny. So then you just do the same with the next one. So now we're at the height of -1 for our y, and we're going from -2 to -1. So just up from that, on the -2 is an open circle. Then you got your bar in between for all those numbers in between. And then at -1, it's a closed circle. And then that pattern's just going to kind of keep following there, and that's what starts making the steps or like the staircase type look. So if I do the next one there, my height is 0, so I'm right on that x-axis. At -1, I'm going to have an open circle. At 0, I've got my closed circle. And then next one there, my height is 1. So go up to the 1. On 0, I have an open circle. Little bar over. 1, you've got your closed circle. And then the last one, our height is 2. 1, we have an open circle. Little bar over. 2, we have the closed circle. And you could keep going with that if it wanted you to graph more, but those are just the ones that we do. But that pattern would keep going for the round up or round down function, or the round up function in this case. kind of with me a little bit? I know it's kind of a lot to take on, but if you can map the stuff out on this, usually this is kind of a helper if you can kind of figure that out if you got to graph it. Okay, we good if I flip? Okay. All right, so next one here. Suppose taxi rate, I'll zoom out so we can actually see it here. Okay, taxi rate is an initial fee of $3 plus 60 cents for each full quarter mile traveled. And then we're supposed to write a formula, T of M, the charge for a trip of M miles. Okay, so we just have to start by coming up with our equation here. Okay, so we know it's going to be the function T of M. M standing for our amount of miles traveled. Okay, so let's start with our initial fee. What's our initial fee? The $3, and that's kind of like our y-intercept value, like our starting amount. So if we travel 0 miles with this taxi guy, we got to pay him $3 for just getting in his car evidently. So we'll go 3 for just our starting amount, plus the 60 cents, and what's that going to go with? The M. Now when we do this out here, we're going to do a couple things a little different. So 60 cents, going to be with our M. It's a little bit tricky here, and I'll try not to do this to you like on the test and stuff, but it's for quarters of a mile. How many quarters are in a mile? What do you say? 4, right? So if we split a mile into quarters, quarters means into like fourths. Not divide by 4, we actually times it by 4, which is confusing because you want whatever your amount is to be times by 4 compared to like the mileage. So what you're actually going to do here is it's going to be 4 times our mile amount, and again, that's very confusing. I'm not going to try to do that to you like on the test and stuff. But now comes into play, before we do our multiplying, we got to do the round down, round up thing, okay? If we're driving in the thing, it says for each full quarter mile. So is this guy going to make us round up or round down if they just want it to be each full quarter mile? Round down, okay? So this guy must be friendly. He must say, hey, if we only travel a quarter mile, I'm just charging you $3 for that. So this is a round down function because this guy's being friendly, okay? Because it says up to each full quarter mile. Okay, so that's kind of our initial setup there. And then again, we had to use that because it's the quarter mile traveled. So then now what we want to do is it says, what is the charge for 0.25 mile taxi ride? So, or not 29. So where do you think that 2.9 is going to go? In for our M, right? So you just take that 2.9, put it into the M. So technically it'd be T of 2.9 because we're plugging in the 2.9 in there is equal to 3 plus that 60 cents per quarter mile. And then in that round down bracket, we'll go 4 times 2.9. And then these brackets work just like if it was like parentheses. So if we're doing order of operations, we would do that action first. Okay, so if we do 4 times 2.9, you got me 11.6. Yep, so that's in our round down function. So I'm just going to rewrite it here so we got it. So yep, so when you multiply that out, 11.6, then we need to do our rounding down. So what would that round down to? 11. So 3 plus 60 cents. Now we can just switch it to parentheses because now we've taken care of the round down function because we rounded it down to 11. And then from there, multiply, so 0.6 times 11 should be 6.6. And then you just add 3 and 6.6. 9.6, or in dollar amount, that'd be like $9.60, right? But yeah, it's the same type of stuff. You just want to take care of that like it's a parentheses thing, solve it out first, then do that action, and then go from there. Okay, last one here. Okay, so we got errand running service charges $38 per hour, billing for a full hour when any parts of an hour are used. So if you go 2 minutes over the next hour, you got to round up. And then it says, what is the charge for running errands for 2 hours and 45 minutes? Okay, so if we're setting up our function here, I'm just going to go f of x. Okay, what's it going to cost us per hour? 38. Is there any initial startup fee? Nope, just that 38 per hour. So we'll just go 38. We don't have to do any plus or minus or anything like that because there's no startup fee. And then here, are they charging us up or are they charging us down for the hour? They're rounding that up, right? So that even if, like I said, if we're there for 2 minutes, they're going to charge us for a full hour. So it's going to be a round up one. Okay, and then here we've got 2 hours and 45 minutes. 45 minutes of an hour. Does anybody know how to figure that out for like a fraction? Does anyone know what the fraction of an hour it is? It is 3/4. So what it would be is it would be like 45 minutes out of the 60 minutes in the full hour. So that would reduce down to 3/4. Truthfully, it doesn't actually matter in this case because we're just rounding up or down, so it wouldn't even matter exactly what it is, but for the purpose of doing it, we'll do it out. So they'd be like 2 3/4 for our hours we're plugging in there is equal to 38. And then in our roundup function, so $2 or 2 hours and 3/4 of an hour. But either way, if we went over 2 hours, what do we have to round up to? 3 full hours. So then it'd be 38 times 3 full hours for that roundup function. Then you would just multiply 38 times 3. 114. Yep. So 114 for whatever that service is. Okay? All right, so you get your book page there, 207, 1 to 16 for Monday.